Hello, this is Mr. Cerisa, and today we're going to talk about the analyzing and graphing polar equations of conics. And so there's obviously three conics, the parabola, the hyperbola, and the ellipse that we need to talk about. I'm going to start with the easiest one, and that is the parabola. And this is a pretty easy problem, so I'm going to start you off here, and then I'll do another one for an ellipse, and maybe another one for a parabola. So let's start off with the whiteboard, and I'm just going to do number 14, or page 686 out of the book. And so just a practice one. Okay, so this equation has r equaling 3 over 1 minus sine theta. So the first thing that I would do, I'd want to identify what type of conic it is, and I know I already just said it, but if you just look here, that's going to be your E. And so in this case, E equals 1, which means that it's going to be a parabola. Okay, and actually we needed to make sure that this is 1 as well. It's always going to be 1 plus or minus a sine or a cosine. So we know that it's the 1's in case, so we can just move forward with that E. And just to further calculate things out, this 3 is our EP. And seeing that E is 1, it really just equals 3, right? So P equals 3, E equals 1. This is the distance of the focus to the directrix. So that's going to be 3 away. Alright, so let me start off with a graph, and this is just a sketch, but you'd be doing it on polar graph paper. I'm going to just set up here and make it look like it's coordinate, but really this is the polar axis. And this is the theta equals pi over 2 axis. And so setting up the directrix, we have a sign, and it's negative. I know there's a bunch of arrows, so maybe take them away, but we have a negative sign. So let me think of it, just think of it that way. Negative sign right here. And that tells me it's going to be below the pole. So I'm sure everybody remembers the pole is right in the middle. So below the pole, 3 is going to be your directrix. So 1, 2, 3. And so there you go, the directrix. Remember, this pole is also a focus. And so the parabola, judging by this, is going to be opening up because the directrix isn't going to hit the parabola. I mean, just look back at the definition and you'll know why. And then so the next thing I would want to do is find the vertex. And so the vertex is going to be halfway between the focus and the directrix. Oops, I missed that one. Okay. Well, sorry, close enough right there. Alright, so the vertex is going to be halfway between the focus, which is going to be at 0, and the directrix, which is at 3. So the vertex will have to be at 1.5. Okay? And so technically, this vertex is at 1.5, comma 3 pi over 2. And so we put that in there. And now we just need 2 other points. And the easiest points are going to be when theta equals 0 and when theta equals pi. Because sine of theta and sine of pi are both equal to 0. So if I put that in there, if I put like a radius with an input of 0, that's going to just equal 3 over 1 minus 0, which of course is 3. And the same thing happens with pi. Plug it in and we'll get 3 over 1 minus 0. Oops, just kidding with that. Okay, and then that's also going to equal 3. So you're like, oh, well, they're both equal to 3, but remember, the first one, 1, 2, 3, has an angle of 0, and it's that 3. And then the pi has an angle, the next one has an angle of pi, and it's this 3. So don't forget about the polar coordinate system. and how that works. Alright, and then, so there you go. There's my 3 points. And then there we go, and here's my parabola. And I have my graph, I have my focus, vertex, and directrix all laid out for me. And of course I mentioned what E was, and that's a parabola. Okay, thank you. I hope that this helped.